A big welcome back to the Resources Conservation and Recycling webinar program. My name is Mitchell Jones. I'm the outreach editor at Resources Conservation and Recycling. It's a pleasure to have you all with us today and to have Roland with us today. A big welcome to Roland. Thank you so much for being with us. Before we kick things off, I'm just going to touch on, more or less introduce the program, as it were. So this is the English language version of the Resources Conservation and Recycling webinar program. It's running every second Thursday at 10 o'clock a.m. Pacific time. Now, this particular program is scoped to the journal one-to-one. So you can expect to find all the type of topics that you would see within the journal scope represented in this program. And we aim to run a balanced program. What that means is that we try to give equal weighting to the topics within the scope. You will not see any particular bias or preferences. We try to cater to everybody's interests who might have an interest in the journal. The only thing that we do aim for is accessibility. So the program is aimed to be as broadly accessible as possible. We want to cater to audiences that may not necessarily work in exactly the research area that the presentation is in, but perhaps work in an adjacent field. So they would potentially find the research very interesting and useful, but they may not know the absolute nitty-gritty details. As a result of that, we basically ask presenters to please refrain from using too much jargon, too much topic-specific, research field-specific terminology or concepts without first giving some basic explanations in an introductory sort of content to their presentation before they dive into the real details of what they've done. Now, registration is necessary for the program. It's free. You just have to register either through the links that are circulated in the Resources Conservation and Recycling newsletter at the end of each month. Or you can also find those links on the social media pages, the Resources Conservation and Recycling media pages, social media pages, so X, LinkedIn, Facebook. And you can also find them on the official web page for Resources Conservation and Recycling from Elsevier. So if you go to the Elsevier page for Resources Conservation and Recycling, you go to the About tab, you will find there the webinar calendar. There you have access to all of the links for registrations for future webinars. You also have a full list of all of our previous speakers with a link to their archived content on YouTube. You can also visit YouTube directly to get that content. So our journal homepage on YouTube is youtube.com/@RCR journal. All of our webinars are live streamed to YouTube and they're all archived also to YouTube. The final point is that we really aim to run a program that meets we run this program for our community and for people who are interested in publishing in our journal. And we really want that program to be valuable to you. So if you do have some feedback for us, things that we're doing well, things that we could improve in terms of our webinar program, we would really love to hear from you. At the end of every webinar, every participant will have the chance to leave feedback. It's an 8-question, 2-minute survey that you can fill in to provide us with some feedback on what you like, what you don't like, and we will read what you write, and we will attempt to cater better to the sort of your preferences and your research requirements, because we do want people to get something from the program. So I'm just going to bring up my screen now. Here we are. So the event program for today, we have had the welcome address. I'm going to provide a short introduction to the journal, just for anyone who may not know necessarily that much about the journal. I'm then going to introduce our speaker for today, Roland, who we're very lucky to have with us. A couple of points on the admin or the webinar etiquette side of things for the event today, and in fact, all of our events. We're going to have an approximately 20-minute presentation from Roland, followed by approximately 10 minutes of question time, but we are flexible there. We want everybody that comes to the event to have the chance to have their question answered. So if you have a question, we will do our best to make sure that it does get answered. And then we're going to have a little bit of information on the next event and then some closing remarks. So just an introduction to our journal for anyone who maybe doesn't know, I suppose you do, but the journal is Resources Conservation and Recycling. It's an Elsevier journal. I think that the scope and the research interests of the journal are fairly clear from the name, Resources Conservation and Recycling. We are interested in systems-wide strategies, technological, economic, institutional, and policy focus, resource management practices, conservation, recycling, and resource substitution, resource productivity improvement, restructuring of production and consumption profiles, and transformation of industry. So if you have any top quality research in those areas, be sure to flick it in our direction. Today, and for all of our events, actually, we ask that people please communicate in English. The reason being simply that we then have a bridging language that we can all understand and communicate together with. Closed captions are also available. They're running right now. Hopefully you see them appearing. If you don't, you can switch them on. Those are potentially useful if you like to watch your webinars without the audio on, or if potentially you don't speak English as a first language and may perhaps benefit from some kind of closed captions. They are there if you would like to use them. If you have any questions over the course of the webinar event, please put them in the Q&A. That's why we're all here. This is an interactive event as opposed to a podcast or anything like that. So please, if you have any questions, feel very free to ask them. I'm sure that Roland would be more than happy to answer them. We also provide the option for you to ask your question directly. So if you would prefer to speak with Roland and ask your question with your microphone and camera, we'd be welcome to, we'd be more than happy to welcome you onto the floor to speak with Roland. You just have to indicate you'd like to do that with the raised hand reaction in your toolbar. And if time permits, we'll be sure to bring you onto the floor to speak to Roland. So an introduction, our speaker for today, Roland GEYER, from the University of California at Santa Barbara, USA. Roland GEYER is a professor of industrial ecology at the Bren School of Environmental Science and Management, University of California, Santa Barbara. Prior to joining the Bren School, he held research positions at the Center for Environmental Strategy at the University of Surrey, UK, and the Center for the Management of Environmental Resources at INSEAD, France, and was a consultant in financial risk management in Germany. In his research, Roland uses life cycle assessment, material flow analysis, regression analysis, and other methods to assess pollution prevention strategies based on reuse, recycling, and material and technology substitution. His work on plastics and the circular economy is widely covered in the media and received various awards. Roland received a graduate degree in physics from the Technical University of Berlin in Germany and a PhD in engineering from the University of Surrey, UK. A big welcome to you, Roland. Thank you so much for being here today. I will now stop sharing my screen so that you are able to share yours.
Excellent. Well, thanks so much, Mitchell, for the kind introduction. Let me bring up my slides for everyone and make sure that you can actually see them. Mitchell, slides are visible? All good. Okay. Welcome to my office, everyone, here in Santa Barbara, California, USA. It's actually a little bit of a gray day today, despite this being SoCal. It's actually not uncommon. We call it May gray, which is then followed by June gloom. It's these marine layers we get in Santa Barbara, but mustn't complain. Thanks so much for your interest in our research. I say our because this is really a joint effort that I'm reporting here, and the main man is actually Jason. He was my PhD student. He did all the heavy lifting here with the regression analysis, the data collection. So shout out for Jason. And I could not do this type of research without my colleagues at the economics department here at the Bren School, Dick Starts, Doug Steigerwald, who is actually a global leader in difference in differences regression analysis, which you will see is what we used in this research. So the paper was published, I think, late last year in Resources Conservation and Recycling, which is, and I'm not being paid to say this, one of my favorite journals, Mitchell. It's a great journal. Keep up the good work. So yeah, you all consider publishing in RCNR. Okay, and I will very much try to stay within my 20 minutes, and then try and leave lots of time for Q&A. Okay, so just to set the stage here, this is about recycling, so material recovery, and it is about the environmental performance or the environmental benefits of recycling. So it's not about the economics, it's about recycling as a strategy for environmental impact reduction. So, just make sure that we're all on the same page here. So, you know, and maybe those things are obvious, but still always worth remembering what are the potential environmental benefits of recycling, right? Without recycling, every single product that we're making and using in this world would have to be made from virgin or primary material. So that's kind of the illustration here. So what recycling does is it collects end-of-life or end-of-use products and recovers the materials in them, or at least some of them, collects it and then reprocesses it into a secondary resource, in this case a secondary material that then can be used instead of virgin material. And what I'm trying to indicate here that this, as a result, the potential environmental benefits are twofold. One is avoided disposal activity. So you see that in the top right, and also in the bottom left, there is potential avoided primary material production activity. So two types of benefits. Just as an aside, right? If we, and probably lots of you know this, if you do life cycle assessments, sort of end of life type life cycle assessments, if a standard, if it's commodity materials, not something hazardous, then a standard result is that the environmental benefits, potential benefits of avoided material production are actually much larger than those of avoided disposal. But there is another thing which Trevor Zink, another one of my PhD students, we actually wrote a paper about, is that if you don't avoid primary material production, you actually don't even avoid disposal. You actually only delay disposal. And that is something I'm trying to sort of indicate in this slide, because it's entirely possible that we use that secondary material that we're generated on top of virgin material and not instead of virgin material. So two things here that are important and sort of motivate the research I'm going to talk about now is that without avoided primary reduction, recycling does not avoid landfill or other disposal. It just delays it. And at the same time, it also increases total environmental impacts because now suddenly there's more production and disposal activity. And so we called this circular economy rebound, sort of because it is very similar to energy efficiency rebound effects, right? It's sort of a social effect, behavioral effect. So now in practice, the displacement rate, so the extent to which recycling reduces primary production, is not going to be either 0 or 1. It could be anywhere between 0 and 1. So 0 would mean absolutely no displacement, like sort of indicated on this chart. And then 1 would be what sometimes I call 1-to-1 displacement. So that means that every ton of secondary material generated from recycling activity would reduce primary production by an equivalent amount. Let's call it a ton. depending on technical specs. So this displacement rate is really a critically important parameter to assess and quantify the environmental benefits of recycling activity, and in fact, any circular economy activity. And in order to explore and estimate displacement rates, we actually need to sort of pivot from modeling research that I spend a lot of time in my office with, to empirical research, and because we need to go out there and find out what happens in the real world in practice. And this empirical research, a standard method to do this is regression analysis. So we're looking for natural experiments out there and then hope that there is data that has a signal in it that we can then extract through regression techniques, and hope that the noise in the signal or in the data is not too large, so we actually sort of get an insight. And that's exactly what we did in this research that I'm now going to report about. So just so you know, this paper, which is on the top here, the curbside recycling increases household consumption, is just the latest output from my group on our ongoing research on reuse and recycling, and in particular, the complications generated by circular economy rebound. So a lot of it is sort of foundational, but increasingly we're teaming up with social scientists like economists to do regression studies to understand this effect of partial displacement. So that's so the background. There's another really interesting study also using difference in differences regression technique, which is the second one down, also published in RCNR, about wastewater recycling and the displacement of potable water, if you're interested, and then more about sort of the foundational work. All right, so now let's talk about this wonderful natural experiment that we have privy to in North Carolina, here in the US. That this is basically, that makes our study possible. So North Carolina, the Department of Environment and Natural Resources, they receive every year a report from local government agencies about waste generation and waste treatment. This is due to a statute that was passed in '98. So the first reports were generated and filed in 1999, and they are publicly available. And so that means that we have this incredible data set where we can look at the total waste, solid waste generation, and also recycling. So blue bin, brown bin, we call it in the paper to make it sort of easy. In 655 local governments, so 100 county governments, 555 municipalities. In that table I'm showing, we're calling it all municipalities, so don't get confused there. That's, again, it's the roughly 655. It's self-reported, so that means that occasionally it's incomplete, and therefore we couldn't use like every single report, but most of them. So it's like what we call a panel data set in regression analysis across 655 municipalities and 21 years. So it's a really wonderful data set. And what the natural experiment here is that during that 21-year time period, different municipalities started curbside recycling programs. So you can see here that just between 2004 and 2018, there was an addition of 125 curbside recycling programs. Also, actually, just FYI, occasionally a municipality discontinues a curbside a recycling program. So we would call that disadoption in the study. And yeah, table 1, I mean, it's just straight out of the paper, just shows you the statistics of the sample statistics of the whole NCDENR panel, as we call it, right? North Carolina Department of Environmental and Natural Resources. So that's the data set, right? In these regression analyses, you have the data set, and then you have the regression technique, the method. And that's the next thing I want to introduce to you. And maybe some of you know more about D&D than I do, and some of you have never heard of it. So I find this visual nice, fairly intuitive. So the idea here is let's look at the visual, not the equation. That the algorithm compares different municipalities that, or actually municipalities that are similar, not necessarily in amount of waste generation, but similar in trend. And then it parses them into the green group. Here's the green line, which wasn't treated. So treatment here means the adoption of curbside recycling, right? So let's say the green line is municipalities that don't have curbside recycling and never had it. And then it compares it to similar municipalities. That's the red line. And that's the time trend, right, from 99 to 2019. And then those red municipalities, they were treated as and treatment just means adoption of curbside recycling. So at that blue vertical line, curbside from 1 year to the next, curbside recycling was implemented. And in some instances, we also look at availability of any recycling system, so drop-off and curbside, not just curbside. So we're making that distinction. And so the idea there is that we basically have a control group, sort of, that's the green line, and we have a treated group, that's the red group. And you can see that there's a difference between the green and the red line, but then there is the treatment adds another difference, hence the name difference in differences. And that's called the intervention effect. Can you see that? So that's between the solid red line and the dashed red line. And that's what we're after, because that is the effect basically of the treatment to the best of our understanding. And then, of course, there may be other things going on, right? So the epsilon, let's go to the equation. So the epsilon just shows noise, right? That's the error term. The delta T is what we call a fixed time effect. So there may be things that are very specific to one given year or a period of 5 years. And that's true across all municipalities. So that is captured in the so-called fixed time effect. And then here, alpha is what we call the fixed municipality effect. So there may be something that's very specific to a municipality, like the amount, the volume, the total volume. So the constant difference between, say, a green municipality and the red municipality, and that's captured in the fixed municipality effect. And that's trying to account for those effects so that the beta in front of the treatment variable, the treatment dummy, right? D is either 1 or 0, right? You have recycling, you don't have recycling. And the beta captures this effect of treatment of having curbside recycling suddenly adopted at that municipality. So it's the beta we're after, and the alpha and the delta and the epsilon are sort of accounting for all the other things that might be going on. Okay, and so here are the results for better or worse, I had to learn that with these regression studies, the results always look incredibly boring. It's just a table with a lot of numbers, and then you have to sort of look and see whether there's actual excitement in the table or whether it's nothing. So 2 stars means it's a very significant effect, right? The error is small relative to the result, and 1 star means it's still significant. And then if there's no star, it means that there's no significance. You can see that the error is actually larger than the effect, right? So we don't even know whether here the effect in the blue model is plus or minus, is negative or positive. And then I was just here trying to match the equation parameters here to the table. So here's the municipality fixed effects, right? We always account for it. Yes, yes, across time fixed effects, always account for it. And then in model 1 is the one that I described for you. And then model 2 and model 3 we actually distinguish between curbside and drop-off. So that's just sort of an additional, it's just different ways to basically query the data set and try and tease signals out of it. And yeah, so basically, and it kind of says it in the abstract, right? What you find in model 1, that the model suggests that adopting any recycling program increased total mass, that's the outcome variable, total mass of municipal solid waste by 8%. Okay, so that's quite something, right? That just providing blue bins, say, to households will actually statistically significantly increase their solid waste generation. So that's what model 1 tells us. And then if we account for the difference of curbside and residential, then you can see that the signal is still there. And it's now the best guess estimate is 7%. And if we actually here have an additional restriction in model 3, which means that we look only at households and we do not allow for disadoption. So, you know, if a municipality actually disadopts recycling, curbside recycling, you could also say that's a treatment, or you could say, no, this is actually a slightly different thing, so we're going to ignore it in the sample. So that's the difference between model 2 and model 3. And you see, again, regardless, the effect never goes away. Okay, so the effect is always significant. This is, you know, we are running the model in logs, which means that the results are all percentage changes. If you run the model in absolute values, then you still get a significant effect. That's in the SI, if you're interested in that. So, you know, regardless how you query the data set, this signal is just always there. And we were kind of, yeah, in a way, hoping and fearing that would be the case, because obviously it's good news from an academic perspective, but it's bad news for the environment, right? So this is not what we want. And then model 4, very briefly, I know I'm almost out of time. Model 4 is different because the outcome variable is actually just trash, just brown bin content, right? So red, the outcome variable is total municipal solid waste. So blue bin, mass of the blue bin plus mass of the brown bin. Blue is only mass of the brown bin. And there you can see if we run that model, we get an insignificant result. So that basically says that adopting curbside recycling has no significant effect on the mass of the brown bin, right? And that, so in a way, that corroborates, right, the findings of the red models. And nominally, the effect is even positive, right? Which is, but not significant, I need to say that, right? So nominally, it actually says it might ever so slightly increase brown bin content. So Yeah, so there it is. So that's the data set. That's the regression analysis we did. Right, it's obviously concerning. You know, if for a while we thought, well, at least it's just 8%, right? Thereabouts, so it could be worse. And then we looked at the actual data, and then we actually realized, oops, no, it is actually worse. And the reason for that, and that's my last slide for you, is that blue bins actually only make up 8 to 9% of total solid waste generation. Okay, so it's not that brown bins and blue bins have, because everything is by mass, right? Not by volume. Blue bins have, you know, like even if it's full, it'll weigh way less because, you know, it has sort of low density stuff in it, packaging, you know, plastic, boxes that haven't been folded. So in our data set, the blue bins on average were only between 8 and 9% by mass of the brown bins collected. That means that a 6 to 10% increase in total solid waste is actually dramatic compared to what we collect in the blue bin. And just here's just sort of a you know, very simple kind of made up example, right? If we only have a brown bin and it says the municipality collects 10,000 tons in a year, and now we have say an 8% increase in solid waste generation when we provide blue bins to households. That 8% is actually more or less exactly how much we should expect gets thrown into those new blue bins. So that basically means that we, you know, like we haven't diverted what everyone suspects, and we were hoping for that. We have not reduced brown bin mass at all. The brown bin mass is more or less unchanged. Remember Model 4? That's what Model 4 says. All we have done is we somehow encouraged households to create more solid waste and then at least divert the excess into the blue bin on average. And that's obviously is not at all what we want, because, you know, I said in the beginning, if recycling does not reduce material production, it does not generate any environmental benefits, right? It may create business opportunities, but it certainly does not decrease environmental impact. So that effect is not something that we want, and that's why, why I'm glad I was invited to present this research. So I'll stop right here. Thank you very much for your interest. And yeah, I'll stop slide sharing and we can move on to Q&A.
So thank you so much for that that wonderful presentation, Roland. And it's I think it's one of the most valuable things, you know, recent studies actually, because it's just so counterintuitive to what people would think would be common sense, you know. So it's very, very interesting. So I will just note now that the Q&A time is open. So if you would like to ask a question, feel very free to do so. I see we have one there already, but I'm just going to ask a couple of things that I found interesting first. We also have, as I said to Roland earlier, we actually had a question emailed in prior to the event,
Wonderful.
which is rather rare, but anyway. So the first thing was, you mentioned this concept of coupling the economic aspect with the LCA aspect. This was one of the things that you spoke about at the start of your presentation when you were referring to some collaborations. Now, this seems to me to be an exceptionally valuable thing to do, which I don't really work in this particular research area, but I guess is perhaps maybe not so common. Maybe you can comment on that too. But this seems to me something that would be very, very appealing for policymakers, for industry, things like this kind of collaboration. Perhaps you can elaborate a little bit more on how this works. How do you incorporate these economic aspects into the life cycle aspects or the material flow aspects?
Yeah, no, absolutely. Thanks for that question. So, just for clarification, I'm working with economists, but just because, the people I work with, they are actually statisticians and econometricians. So they are kind of masters of what is called regression analysis, sort of teasing those signals out of data sets. And as you said earlier, I'm a physicist by training. We don't do regression analysis. I spent 7 years studying physics and mathematics, and we did not really learn about regression analysis. So this is just not something I had in my training, and then I pivoted, and for better or worse, I'm now saying, okay, I'm an industrial ecologist, right? I study material and energy flows in production and consumption systems, and again, this is not currently sort of something that is in industrial ecologists' toolkit, typically regression analysis. And so I would love to kind of encourage people to look into that, to consider that, because it's really powerful. And one of the reasons is that I think if I'm just more and more convinced that the true bottlenecks are actually behavioral rather than technological. I hope some of you will sort of share that frustration that we kind of, at some point we felt like all we have to do is show the world that there are these great technologies and these kind of systematic changes that we could adopt that really move the needle in terms of environmental impact. And then we did, and then nothing happens. And then you suddenly realize this, maybe it's all about social dynamics, right? Rather than just technological feasibility and economic feasibility. And then suddenly you think like, oh, but that's not what I do. That's not what we study. We're very good at studying technical systems, but at least I speak for myself, right? I've thought like, oh, I don't know how to do social science research, right? And that's when I thought like, okay, I need to find some people. And that's when I walked over to the economics department, because I thought like, let's think, let's find some people to work with. And those econometric people I found they're just really nice and very interested in sort of looking at new systems that they haven't studied before. So yeah, thanks for the question. I think there is vast potential to sort of integrate this kind of regression analysis and econometric studies into our world of industrial ecology and systems analysis.
Absolutely. And I think, and it takes a certain kind of person to go across the corridor and seek those kinds of people out, because we do all tend to get stuck in our little boxes without realizing that, well, maybe realizing perhaps, but turning a blind eye on the fact that we really all need to work together to find these.
It's a little bit scary, like I do remember sort of thinking, okay, do I really have to know? I learned so much already. Do I have to study this now? But I'm not the expert. I will never be a regression analysis expert like Doug Steigerwald will be. But I know enough now to work with him and to train PhD students to get very quickly much better than me in those things, and to understand whether, to the point that there's a real result, or maybe it's mostly noise, and that's good enough. Right. And that's the value of just teaming up with others. And the other thing I'll say is it wasn't an instant gratification kind of journey, right? You sink a lot of energy into the project, and then the rewards come after, I don't know, a couple of years, but it's definitely worthwhile.
Well, good on you for taking that leap of faith. Yeah. The other thing that I found very interesting was this, you had data available to you from the North Carolina government authorities, more or less. I was
Right.
just wondering, is this, I mean, obviously this is critical to getting accurate, useful results that are actually going to have some kind of impact on our societies. Is this a common practice to be able to have such data availability and cooperation from government authorities?
It's certainly my experience here in the United States. You know, there is, gosh, I can't think of it now. So this is publicly available data, right? There is, what's the act called? Someone will help me out. You know, like the something public, something act. And so they actually have to make this data available. You know, because it's government funded activity, and occasionally there may be a little sort of NDA confidentiality concern, but mostly it's data that's right there to be used. And in my experience, the environmental state departments actually, they have great people and they're passionate, just like us, about you know, exactly that: resources conservation and recycling, and so they are more than happy to help out. So that's my experience. For me, the hardest thing is to actually find, you know, become aware of these data sets, that they actually exist out there and that we could actually use them. And I have to be completely honest, it was Jason, my PhD student, who found that data set. So
Okay, so
he
good
did
job, Jason.
sleuthing, and yes, thank you, Jason. I mean, that was really amazing. We were so excited when he came and said, like, "Oh, I think I've got something here." Yeah.
The other thing I wanted to ask you was, okay, this is very interesting, these social factors. So again, and this is not the first time I hear this, it's a recurring theme. I would risk to say, hazard to say that it is a recurring theme, that a lot of our technical studies end up being stumped by social issues. You've already crossed that bridge of trying to establish collaborations with these economists to make use of new data. Do you have any plans to maybe team up with social scientists or something to try to, have you considered how you're going to try to get to the bottom of really what the problem is, the social aspect, or is that sort of outside the scope of what you're intending to do?
I mean, not necessarily. Just be clear. So economists are considered social scientists, right? So, and within the social sciences, there's sort of this divide between quantitative methods and more qualitative methods. You know, and they can get quite heated about what's the right method in social science. I'm completely agnostic. I think they're both great. But obviously here we're going, you know, we're going with quantitative methods. So we're looking sort of quantitative social scientists, right? And you can find them in the economics department. You find them in political science. You can find them in like psychology, which I think is kind of what you're getting at, is to
Yes.
really get, you know, like what is the psychology behind it, right? Sometimes you find them in interesting places like the marketing science department of business schools. They actually, you know, they're really interested in what makes people tick, right? And how people make consumption decisions. So they're actually really sophisticated when it comes to that. So if you have a business school on campus, that might also be a great place to look for collaborators. And yeah, and I think, you know, some of that, sometimes you say, right, this is such a non-intuitive result. And to that I would say, well, it kind of depends, right, where you come from. And I think you know, I'm coming from this sort of physical world where I just kind of study flows. And then you kind of, you know, like I remember, you know, doing my thesis on reuse and recycling, and everyone was just saying, well, if we have more recycled material, it'll displace virgin material. What else could it do? Right? And that's just because we had this sort of strange blind spot there, right? Or sort of yeah. And then you talk to social scientists, and you know, and you say, oh, it might actually increase total consumption, and they just look at you and say, and your point is,
Yeah, they're
like,
not surprised.
of
Yeah.
course, that's economics 101, right? So that's another, I think, value to reach out to other departments, because they just sometimes you realize that you have this set ways of thinking that you don't even know you have.
So it's again speaking to the critical importance of collaboration and getting different
Absolutely.
perspectives.
Yeah.
Yeah,
Yeah.
if you want to find the actual truth.
Yeah.
We have quite a few questions coming in, so I
Oh,
might
lovely.
skip one of my questions, but I did have one that I wanted to ask you before I maybe switch to the audience. So you've got these results here, and I was sort of wondering, how do you go about, what do you do with these results now? So you have results based on government data. How is there any way to incorporate these results? Is the government interested in these results and how they can change their programs to try to actually reduce consumption? I was just interesting. I don't know. Initially, I sort of had more of an impression that maybe you'd partnered with this department, and then perhaps you had
Oh, okay.
some recommendations, or I was just interested in their response. But okay, I understand now it's a little different. But perhaps you have some insights into how these results can actually be transferred into our societies, our communities in a meaningful way, if it's possible.
Yeah, absolutely. Sorry, I'm a terrible multitasker, and I got interested in the questions, but I need to separate that.
No.
Because I only can do like one. I really can't multitask. So yeah, no, you're absolutely right. With North Carolina, I mean, Jason had really good discussions with some folks at the department, but we just to understand the data set and make sure we're using it correctly. I am, I'm here in California, and the equivalent department there is called Cal Recycle, right? It's the State Department, the department at the California EPA, that's in charge of resource recovery and recycling. And they're great folks, and they are aware of these issues, and I do actually collaborate with them on various projects, right? They are very busy at the moment implementing Senate Bill 54, which is about plastic, the big plastic pollution reduction act here in California, and so I'm working with them on issues, and I think like that way, these sort of research of that sort kind of feeds in to public policy, and then also here in Santa Barbara, I'm I have a few really good contacts in the County of Santa Barbara Public Works Department. And again, they're very passionate, and they're very sophisticated actually, and they know these things. So it's not that, we're sort of trying to put numbers to at these effects, but it's, they're kind of aware of it. When you go to a tour of the landfill and our county-owned material recovery facility, one of the first things they will tell you is that we have an incredible diversion rate at the MRF, but also just know that the County of Santa Barbara, the average solid waste generation is between 2 to 3 times as much as the national average. So yeah, which is really, where they think like, oh man, that's really frustrating. So, and like I think they're trying very hard to get the message across that really it's about source reduction, is like, that's really where it's at. So ideally you wouldn't even, well, you'll always need the blue bin, but like, and that's kind of, I think there was like one question that I've seen is like, like everyone is already a little bit down on recycling at the moment. Not everyone, but there has been some, critique, particularly in the context of plastic, right? And our sort of abysmal plastic recycling rate in the US. So is that going to be sort of the last nail? Is that meant to be the last nail in the coffin? And to which I would say, no, ideally the opposite. So I have I know colleagues that have kind of given up on on recycling, to be honest, but I'm not one of them. Let's be clear. So I think reuse and recycling does have enormous potential. I mean, that's what the LCAs show, is that it's just that we need to make sure that it reaches its potential, and we mustn't be naive about unintended consequences or sort of regrettable actions, right? And I think what this kind of research tells us is that, yes, collection is really important of recyclables, but it's just as important to kind of tell the public and those households that this does not mean that you don't have to worry about how much you consume, right? Source reduction is still right at the top of the waste hierarchy. And recycling is what we do if source reduction doesn't work for whatever reason, right?
Yes, makes total sense.
Yeah.
So I'm going to move now to the questions from the audience. The first one I have is the one that came in via email. So I'm going to read it to you. Since your fantastic study of global plastic production in 2017, has the global virgin production stayed on track with the 8.4% CAGR? If so, that would put 2024 production at 785 million tons. That is the number I use in presentations. Should I change it? Thanks very much, Joe Ackerman, University of Manitoba, Canada.
Oh, wonderful. Yeah, thanks for the question, Joe, if you're there. But the so the growth rate, right? The annual growth rate is no longer 8%. It's more like 4%, 3 to 4%. And the one thing I always tell everyone is that don't say plastic production grows exponentially, because it doesn't, right? That would mean a constant growth rate. But the growth rate is actually kind of, I'm not sure it's declining, but it's certainly not constant over the years. So for whatever reason, the best fit historically is actually a polynomial fit. It kind of fits the historic production data, like almost, like the R squared value is like 99.7 or something crazy. And for better or worse, we're still sitting on that trend. So that's the globally unfortunate news. So we're still growing at that sort of declining annual rate. So we're just writing a manuscript to update that data set that Joe referred to. And I don't know what our new projection says, to be on the top of my head, but it's still somewhere around there, 700, 800 million metric tons in 2050. So yeah, we have yet to bend the curve of virgin plastic production globally, unfortunately. Yeah.
The next question we have here from Mario Grosso. He asked, what's the outcome of the graph? Now, I saw him ask this question, or the time that he asked this question, you had your graph there that was the regression analysis. So you were explaining the regression analysis when he asked this question.
That the parallel trends figure. So it was that, right? Yeah. So that was trying to the outcome would be at the back end. There was this, when the red curve after treatment had a separate slope, a slope that was different from the green slope. I don't know if I should pull that up again. You let me know, Mitchell. But it's based. Maybe it makes sense. Can you see it?
Yes.
Okay. So can you see my arrow, by the way?
Yes.
Okay, perfect. So, right, so the dotted line and the green line, that is called the parallel trends assumption. So that's basically saying if the red municipality wasn't subject to treatment, it would keep going at the dotted trend, so a parallel trend to the green municipality. And that parallel trend assumption, that's key to difference in difference regression actually working, right? So that's and then if we observe this diversion from the parallel, the counterfactual parallel trend, that is the outcome. So the difference that I'm kind of hopping between here, that's the intervention effect. And there's another question right below it, right? What is are the results not, maybe they're driven by something else, right? And there's a really a good point of maybe it's because recycling gets implemented typically more at wealthy communities, and so how do we account for that? And we do feed we feed in sort of other explanatory variables, demographic variables, as controls to the extent we can. But I mean, yeah, in the end, that's the one question with the regression analyses. It's very hard to be completely certain that this is 100% what's going on. And then I saw another question here about correlation
Roland,
not be.
make sure if you're going to answer another question, just make sure you read the question
Oh,
aloud.
absolutely, yeah.
Yes. Maybe you could also read the previous question, just so we have a record of it for the archive.
Right. So Hadi Chapardar says, as I understand, you found an association between independent and dependent variable, not a causality. So what Hadi refers to is this famous saying, correlation is not causation, right? And that, of course, is true. Why we're relatively confident that there is a causality going on here is that we're relatively confident that there aren't any. We checked sort of for major endogeneities, which would sort of suddenly create a circle, and then you don't know what's cause and what's effect, and we couldn't find any in these statistical tests. And there is in the psychological literature, it's been, and we mentioned that in the introduction, we reference that literature a little bit. There is a well-known effect that I think some people call moral licensing, right? They are sort of, for example, there are actual experiments that people did where they had their groups cut out shapes out of paper, and then they did this in a room with blue recycling bins and in a room without blue recycling bins, and consistently they get the results that the groups that have a blue recycling bin generate more paper waste when they cut out the exact same shapes out of the exact same paper. So that and that that's a real experiment, right? This is not a regression and a sort of quasi-experimental that what we did. So there is this moral licensing thing is real. So it's there. We know it exists, right? So we think that's something that's going on here that anecdotally, even I'm, subject to it, where you feel like, well, at least, like I recycle, so I don't have to feel too bad that now I just bought something that's triple packaged rather than, just comes loose, right? So anecdotally, I can relate to this effect, and we know it exists.
Very nice. So I'll read you the next question, Roland, unless you'd like to read it. But we just have to make sure that we read them aloud so that people we have a record of the question.
Sorry about that.
No, not at all. As a social science person, really encouraged to hear the significance of behavioral change. Do you think for recycling to work, the bottleneck is sorting waste correctly, or the behavioral change is so hard that recycling is not really a true solution to waste?
Right. Yeah, I think we touched upon that a little bit earlier, right? Is that we're at least I speak sort of for my experience, we're so used to sort of in the waste hierarchy, at least in this country, to go straight to number 3 in the hierarchy, right? To sort of not even bother with source reduction and reuse and go straight to recycling. And I think what that research sort of suggests that there are real pitfalls in that, and that we need to, there should be maybe more efforts in emphasizing the huge potential of source reduction and the importance of source reduction, and potentially also the promise or the potential of actual reuse deliveries, reusable delivery systems. I know that's something that people are starting to talk about again in the context of reducing plastic waste, right? Whether it's here in California with SB 54, it has reduction targets, not just recycling targets. And I know that, when it comes to the global plastics treaty that's being negotiated at the moment at these INC meetings of the United Nations, that people started talk a fair amount about reduction of plastic use and also reuse delivery systems, which I find very encouraging. So, yeah, I think sorting is almost, it's again, it's almost too late. I think sorting is very important, right? Optical sorting has made a big difference in MRFs and in misidentifying materials. But in a way, when the blue bin does not reduce the brown bin weight, I think it's we already failed right there, right? And that means we need to intervene upstream.
We have another question. In light of negative publicity about recycling doesn't work.
Right.
How do you feel like this information can be translated to the public? Brackets, I'm in North Carolina.
Right. Yeah, thanks, Becca. That was the one I was addressing earlier without reading it out aloud. I apologize for that. So that's when I said, I'm not in the camp of let's just abandon recycling, right? I think we need safeguards somehow that ensure that recycling works, which means that we need to somehow get the message out there that recycling, the point of recycling is to use less virgin material. And somehow make people realize that that's what it is. Yeah.
And we had a last-minute comment come in from John Hatz. Do you think making the public aware that not all plastic is recycled will reduce the amount of post-consumed plastic that is generated?
Wow, man. I would hope so. Of course, the plastics industry would be extremely quick at telling you that, well, if we just switch back to other materials, glass, metals, paper, they also generate environmental impact, right? And now how do we make sure that we're not making things worse or leave them just as bad by just pivoting to different materials? So I think that, the hope would be that we're thinking really hard about reducing material throughput, that we somehow become really serious about decoupling service delivery from material throughput. And I think that, and I feel like that's almost always been the project of industrial ecology. But now I think we've gotten more sophisticated in thinking about, sort of unintended consequences and behavioral effects. And I think that's a good thing.
Well, that's all of our questions now for today, and we're also out of time. But what a wonderful discussion, what a wonderful presentation on such an interesting topic. Thank you so much, Roland, for your presentation. I think everybody really enjoyed it.
Well, thanks for having me on, and everyone out there, thanks for being interested in the work and in the issue in particular. So, and yeah, go out there, find yourself a regression analysis expert, and it's a wild journey, but absolutely worth it.
Be sure to, you're saying be sure to buckle in for a wild ride.
For sure, yeah, for sure. But I think that's a good thing, right? That makes life exciting.
Absolutely. So just the closing remarks before we sign off. The next presentation will be from Mariano Martin from Universidad de Salamanca in Spain. He's going to be speaking with us on, or his presentation will be on tracking end-of-life stage of chemicals, a scalable data and chemical-centric approach. That webinar will be Thursday, the 23rd of May, 2024, again, 10 o'clock a.m. Pacific time. So be sure to join us for that if you have the chance. So yeah, a big thank you again to Roland for his wonderful presentation, and a big thank you to everyone for coming. And I suppose I will see you next time.
Excellent. Thanks so much, Mitch. Thanks, everyone.